In a few minutes we're going to see how mankind has been fooling themselves with an implied meaning of the conservation of energy. Energy can either be created or destroyed. That law assumes a sealed system, and here we have a sealed system. In all our devices, we're taught that the energy is all consumed in running our device as it flows from the battery. All our devices run on current flow, and that's all. Voltage is what it takes to overcome any resistance in order to get that flow to occur. So how much energy is actually consumed in our device? In order to see that, I have two supercaps in series with running this motor from this battery, and there's a total of 2 farads, 1 farad each. They're 2.7 volt supercaps. Now these supercaps have almost no internal resistance as compared to a battery. The only resistance that would occur from these is as the voltage pressure starts to build, which will slow the current flow coming from the battery. It's much like having a tank. If you were filling it up with air, your pressure is going to increase if you don't have some escape for it. So what I'm going to do here is a runtime test on this motor. I ran this through a cycle already in charging the caps, and that's the voltage that the motor stopped running at. So all I'm looking at is the runtime of this motor. So that's going to be the baseline for the start of this test. We're going to do charging the caps. This is a very simple version of an energy doubler. Which you'll see when we go over the figures. I'm going to remove the battery. We're going to do a discharge test. At 1.24 volts charged up, and I'm running this motor in the same direction so it's more accurate. The voltage is settling out there, 1.23. The energy that flowed out of that motor was not all consumed because obviously it charged up the caps. So we're using energy more than once. Here we have the results of the test. The charge and discharge voltages were the same. A 44-second run time in a charge and a 39-second run time in a discharge. That's a difference of 5 seconds. 5 seconds worth of the average energy flow is all that was consumed by the motor. The rest is what we're normally throwing away. The conservation of energy law is correct, and that's a good thing. The implied meaning of the conservation of energy law is a matter of the reader's interpretation, which can lead to an endless debate. Thanks for watching.